Just give us a couple more minutes. We'll
Yeah.
get started once I think a couple of people yet to join.
And we see them popping up, and there seems to be quite a crowd. Let's see if I can take a look. Let's turn on the gallery. Up, there we go.
Good evening, everyone, and we are ready to start today's session. Today is the 10th session in this AIM Prime program, and today's session is around solutions engineering for deep tech startups. The session is going to be hosted by Dr. Nevan Hanumara and Dr. Chintan Vaishnav. Let me briefly introduce Dr. Nevan first. Dr. Nevan is a research scientist in MIT's Mechanical Engineering Department, where he focuses on human-centered design of healthcare technologies with an approach that is collaborative, translational, and entrepreneurial. For over a decade, he has co-taught MIT's Medical Device Design course and formerly served as the program manager for MIT's Tata Center for Technology and Design. In parallel with MIT, he works with and mentors multi-healthcare focused startups in Cambridge and worldwide, and serves as an advisor to the New England Medical Innovation Center. On a lighter note, one of Nevan's main life goals is to find the best pastry shop in every city that he visits. So that's all about Nevan. Dr. Chintan Vaishnav, he is a socio-technologist, an engineer trained to design and build large-scale systems that possess both human as well as technological complexities. Presently, he serves as the mission director for Atal Innovation Mission, a flagship initiative of the Government of India under the auspices of the Niti Aayog. Chintan is on leave from MIT for his present assignment. As a teacher, innovator, and entrepreneur over the past decade, he has split his time between teaching and research at MIT and living and working with rural communities in India to build solutions that can overcome constraints fundamental to improving human conditions. He is a co-founder of both for-profit and non-profit organizations and serves on several boards. So with this brief introduction, let me welcome both Dr. Nevan and Dr. Chintan to this forum and requesting them to take it ahead.
Excellent. Thank you so much, Mugdha. It's wonderful to be with you all. When we, Nevan and I have co-taught this content in several different settings. When we were drafting the AIM Prime program, that is the Venture Center team and the AIM team were drafting it. We thought that once you go through one level of conceptualization of your solution, it will be useful to make it iterative and come back to it with a more sort of a engineering physics type of fundamental lens to look at the same solution. So that's the kind of exercise that we are hoping to undertake here. You have two people sort of guiding you through this, as you heard, Nevan and me. And Nevan's going to be your teacher in front of the classroom, and then I'm going to be the co-teacher who will look at all the various responses that you will be filling out and then guide the discussion. So that's how we're going to divide it. Throughout this session, there will be 4 exercises to fill out, and we'll take a pause there, and I will put out a link to these exercises that you can sort of open and fill it out, and then we can have a conversation about it. We've tried to organize this such that there is at least as much work that you will do as we will talk about. So we are trying to not make it talking centered, but trying to make it doing centered. So that's just a very quick introduction. And with that, let me hand it over to Nevan.
Yes, good morning for everybody. Normally when we teach this course, you'll find us running around the room like 2 hyperactive bunny rabbits. as we get the participants to fill out their information on poster boards. And those poster boards grow and multiply throughout the day. What we did is we took 2 courses, a medical device design course, which is basically a fundamentals of engineering design course. And we took a Sloan course, which Chintan teaches, and we smashed them together. So we took 2 12-week, 14-week courses, put them together, tried to teach it in 2 days. And now we're taking a third of that material and we're going to try to deliver it in 2 hours. And we're doing it in different locations by Zoom. So it's an experiment. So at the end, we'll also ask you for your feedback. Every time we teach something, just like with startups, we're doing experiments, we're testing, we're trying new things. We're very open to hearing from you. Chintan's going to be monitoring the chat. So if there's questions or we've lost people or you just have an idea you want to interject, absolutely feel free. This is, as Chintan said, this is not about us delivering material onto you. It's about a 2-way discussion. So with that, let me give you, just a little bit of the context. As designers, we want to think about first, of course, is there a customer? What does that customer need? That should be driving everything we do. When we wear our researcher hats, oftentimes we're trying to push the boundaries of science. But if we don't take that next key step and say, how can we take what we've developed? How can we take these technologies and translate them to actually touching a customer need? Then we don't actually have a product. So today we're going to be wearing our startup hats. So we start with the user, and we know you've had some excellent lectures ahead of this on what the users need. And we know that coming afterwards, you'll also have some fantastic lectures on understanding how those customer needs actually create market pull. Market push is a lot harder. But if you have market pull and you have customers who want something, can you build it? Is it possible? So that's the kind of structure we want to take you through today. We want to take you through something that's called the deterministic design process at a high level, at an accelerated pace. But it'll show you how we think about putting a technology together. So we want to give you 3 takeaways, main learning objectives for the day. You've crafted a value proposition. All of you have an idea, and you're pretty certain people need this idea, that it will somehow create value for a customer. But that creation of value needs to be turned into specific engineering specifications. So that's our first step. Then, as we flesh those out, we want to share with you a tool we use, courtesy of Professor Alexander Slocum, who I did my PhD with and who I have co-taught with for well over a decade. I don't want to really think about that. But how do we flesh those needs out into an actual engineering design? And then how do we think about validating that design? And of course, what are the key pieces that have to work? What are the pieces that we can deal with later? Because as a startup, you're tight on cash and you're tight on time. So you have to focus on the most critical module, which is essentially the most critical element on which you spend your money, and that must work before all else. So we want to take you through those 3 steps. The references here below, we'll share. I think the link has already been shared with you. Feel free to download that. It's free. It's for everybody. It's for the world, actually. So with that, jump into today's schedule. As I mentioned, we'll take you through an accelerated version of our structured design process, from making sure you have a clear mission statement, your requirements, turning those into an actual strategy, an actual concept. Take a quick break for some coffee in, coffee out, or chai as the case may be, and then talk a little bit about modules, make sure we can think about our physics evaluation, and then we'll hopefully try to close out on time. But we're willing to stay later, of course, and spend more time chatting after the more formal session.
Nevan.
Yes, sir.
We have we can go until 7:30, so I think it will probably we have more than enough material for that. So okay,
fantastic.
Just FYI. Yeah,
fantastic. So we want to just start out with kind of a silly example, but it's one that will carry through today, just because hopefully everybody has a little familiarity, even though we don't want to, with the problem of mice in the house. They're particularly prevalent in New England because we build our houses with wood and with hollow walls. So invariably in the winter, you'll hear some scratching noises from places you don't want them. But if we think about our little straw man problem, there's been a lot of effort, but mousetraps really, the old-fashioned ones, they haven't changed that much. So traditionally, what you really have to do, if you think about the traditional way of catching mice, whether you use a kill trap or a non-kill trap, you have to somehow put something out, bait it, try to find out, does the mouse prefer, French cheese or American cheese or peanut butter? Those three are all good options. Preferably, I think smelly French cheese is the way to go. Wait for the mice. They kind of mosey out and we eliminate them. So overall, we have a very inefficient process. And of course, if we use things like bait, we use things like snap traps, they're just not safe. So this is where we start with this customer need, that there's a customer, the customer is your busy homeowner who doesn't have time to deal with this. He or she wants something better. So let's jump into why do we prototype? Well, we put this little graph together to kind of help us break out the psychological trap that you have one chance to make your product perfect. Well, that's not the case. As engineers, as designers, we're always prototyping. But the key is to start with that cardboard, low cost, low fidelity prototype that captures the fundamentals. In this case, let's take a toaster. The idea is we want to make a toaster with a better user interface that lets you see what's happening to your toast, so it's not a mystery. So do we need to build the full mechanism on the right at the first time, or can we start with a prototype that gives us some knobs we can turn, even if they're in cardboard, a screen, maybe we can put a cell phone in there and use that as our screen. That allows a user to quickly say, I like this concept, or I don't like this concept, and we get fast feedback. So there we're introducing the idea of we create some sort of test. That's what the whole goal of a prototype, the whole goal of what we'll show today is to get you to that minimally viable prototype that will allow you to find out, are you on the right track? Do you need to retool? I've been involved with many startups who right in the middle have taken a big turn, but what will determine whether they can make that turn or not is how far down the line or how far into the engineering and the cost process have they gone before they make that change. And of course, as you go further down to a finished product, once you go from cardboard to hard tooling, your cost of changing that product just increases, maybe linearly, maybe exponentially. Of course, if you're following a structured design process where you do keep that customer in the loop and you're testing as you go, you are going to reduce that probability of change. So if we create a cute curve and we talk about what is risk, well, risk is kind of conveniently defined as the probability of something going wrong and how much that occasion of something going wrong is going to cost you. So we can say your project risk peaks somewhere in the middle. Early stage, very low risk, very low cost. As you get into the middle of the project, hopefully, you're going to actually, that's where you start expending a lot of money and a lot of effort. So as you progress from left to right, you need to make sure you're on the right track. And at the end, ideally, although the cost to change it will be very high, your probability is very low. So overall, you've taken the risk out of the process. And that's what we're always trying to do as engineers. We're the people that pack extra socks when we go somewhere. Why? Well, you just never know when you're going to step in a puddle. So we're risk-averse humans, but we want to use that to our advantage. This is the area we want to talk about today on the left. So this process that we teach and that seems to work pretty well, that's very close to what's used in industry, is kind of 3 stages. You want to spend a lot of your time discovering what it is that your customer needs. You've kind of done that, problem identification, turning that into the requirements, and then using that to drive your main design strategies. And your strategies aren't your finished product. That's a mistake. If you start trying to design your finished product, we get a medical condition that's referred to as CAD-itis. I don't know if anybody's familiar with that condition, but we've all suffered from it. It's when you have the most beautiful, detailed CAD design, 300 hours of work in SolidWorks or Autodesk Fusion, and the psychological barriers to changing that, and again, the cost is huge. So the idea with strategies is you want to come up with a broad set of ways that you could solve the problem and use analysis to reduce that complexity and make a selection. Once you've kind of been through this very structured process, I hesitate to call it brainstorming, we then start developing that solution. We take our favorite strategy, turn it into a concept, do more analysis, prototype, break our project into modules, identify the most critical module. And the reason we want to do that again is that's where our cost and that's where our biggest risk lies. Detail engineer that, and then demonstrate, build that prototype, put the bits together as good as you can, test it, whether it's in the lab, whether it's with the focus group with customers, whether it's with an initial release, debug it, and of course, always keep good records and seek feedback at every step. So that's why I think this whole course, this community, this course is put together is important, is because it gives you not just a chance to work on your startups, but hopefully also a chance to contribute to other people's startups. Because the reality of the startup path is it's hard. We need feedback, we need the support of each other to be successful in a startup. So it's very, very important that this be a supportive community that will help everybody, and ourselves included, grow what we're working on. We want to, of course, start with the important thing of don't forget to look at what's been done before. You may think it's a great idea. It may be a great idea. There may be a strong customer need. But if you haven't thought about the prior art, you might be missing the fact that it's been tried before and failed, that there's a great idea out there that's just waiting to be improved upon, or you might learn something completely new about the market. So I categorize the types of prior art that as an engineer, as someone developing technology wants to look at in 5 boxes. So of course, there's patents. That's the one most people think about. And very close to patents, in case there'll be also some papers, because often patents and papers go together. This is putting a little bit more of the academic research hat on, but they're very useful. Any high-tech project you're working on, you do need to look at the literature. Don't just read the Times of India and see what people are saying. You have to dig into the technical journals. We're working on a project right now with the team in New York on oxygen concentration, and we've gone very deep on understanding the fundamental physics and what are causing failures in current products on the market. And then, of course, you take a look and see what is available for sale, but not just what's available for sale, but also what's been tried in the past and what has failed in the market, because that's informative. And frequently when you find a product, it becomes a recursive process. So you don't just say, well, I found a product. You take a look at the company name, you go backwards, you take a look at the patents, especially when you're making a tech product. So what's the underlying technology? That'll be revealed in the patents. And if we go back a little further, you'll often find some papers that explain it. So these are linked ideas. Those are the classic 3 prior arts we look at. But we also want to think about, I have got my pen stuck. That's not great. Come on. There. I want to think about 2 other resources, presentations and people. What I've learned is secretly, there are often very talented people in companies that have created presentations to just summarize not so much their secret internal knowledge, but just the state of the industry. And if you can access those people, they'll often share with you their presentations. And those can make a world of difference in understanding something complicated. And what's the general gestalt? So those are the kind of the 5 things we want to look at, and those feed into our design process. Once we've done our background, once we've done our own market discovery, we then need to make sure that as a startup, as a team, we're actually all working on the same project. One of the biggest killers of startups is they look like research labs where, yes, everybody has matching polo shirts, but not everybody knows what the goal is. And then you have massive fragmentation where everybody is running small experiments, but they're not coordinated. They don't apply to the same Gantt chart. So one of the ways we do that is we make sure any startup we're working with has a strong mission statement. And people think it's hard, it's complicated. No, mission statements can change. It really is just a crisp statement that answers 3 questions. What are you actually doing as a team? Who are you doing it for? And by corollary, why should they care? That's the customer. And finally, avoid adding features. That's the reason we do the mission statements and we stick them on boards. We try to keep them visible. It's very easy to go, oh, but that would be nice. Well, yes, write that down. It's a good one. But if you don't need that feature, don't worry about it at the get-go. Unless that feature critically creates impact for item number 2, the customer, then don't worry about it. Add it later. It's a nice to have. It's a revision 2. So we put an example of a simple mission statement here. We want to provide those busy homeowners. Okay, that's number 2. What are we doing? Something that's fast, safe, and clean way to eliminate mice. Great, that's number 1. And we want to make sure that it's more effective than existing technology. That's number 3, so that we're not just a Me Too product. And how we communicate the fact that it's more effective than existing technology with more than shiny marketing, that's something we'll talk about later today or later this evening. Okay, with that, Chintan?
Yep. Okay, with that, here is the first exercise that you can fill out. I put it in the chat box. 1 per team would be great. And there are going to be 4, as you see, 1 of 4. We're starting with the mission statement. And each of these forms will ask you the project name. If you can maintain the same project name for your team across all 4 forms, that will be excellent. So once you fill this out, please hit the submit button so I see it, and then I can call on people. So let's take 5 minutes and fill this out, please.
To the organizers, can we send everybody to their rooms, or do we not need to send them to the rooms, Chintan?
If they're going to talk as teams, please send them to their rooms.
Yes.
Yes, the room should be open now, and the participants can select according to the team name, and in the meantime, I'll be putting them in the teams as well.
So Dr. Chintan, just a quick question. Can I share this link on the YouTube also?
Absolutely. This is on YouTube. Are there registered teams?
No.
No, then don't send.
All right.
Because we won't be able to have them participate.
True.
Anmol, can you move them to the rooms?
Yes, people should be able to self-select as well.
Yeah, I can see it. It's just that I don't see people moving to the rooms. So
yeah, if they plan to work as teams, that it would be great to move into your room so that you can.
under more, Harish, you can see, just click on the more tab. There'll be breakout rooms.
And then you can join your own breakout room as per your team.
If you are the only person from your team here, you don't need to move. That's
Anmol, just please look up the comments. There are some issues there.
Yeah.
Okay.
Tulsi can't see the room.
Under more. Uh, Anmol, the link that's showing up is assign and not join.
Yeah, yeah, yeah. Just give me a couple seconds. I'm trying to work that out. Yeah, you should be able to see it now, everyone.
Yeah, it's working. Chintan, since the request is to do one form per team, I think they should
Yeah.
discuss and then decide who fills up the form amongst them.
Yes, please. That's right.
Yeah.
Yes, they are all not. Yes, they are in different locations, so that makes sense. Yeah.
Yeah. Request every Anmol, you can just convey it to the rooms, please.
Yes, I'll broadcast that message.
Yeah. Those who are still in the common room, did you want to uh, pick up one of the rooms, breakout rooms corresponding to your team, please? Just go to more. Pawan Kumar, Murugan, you can all go to your rooms, please. Latika, Paritra.
And then future breakout, they will automatically get assigned, so they won't have to go through this one more time. It will auto send them to the rooms.
Okay. Okay. Aritra, Evat is. Then I think you can give it a shot. Go ahead and fill up the form for Evat. If oh, Evat, somebody's there. Uh,
Okay, I'm seeing some responses come in. Looks like I have 6 responses, so 7 now. So let's give it a couple more minutes.
yeah.
I'm looking at the rooms. I'm just going to step into a room and see if people are doing things.
How many teams do we have today?
So overall, there are 25 teams
Yeah.
as per the, but some of the team members may not be there, hence some rooms might be empty.
You would expect around 15 to 18 teams should be around that number.
Okay, great. Okay, I have 9 responses.
Sai Prasad, why have you not joined your room? Your teammate is there.
Yes, I joined my room and then I was alone. That's why I came out.
Your
to
teammate
see.
is there. What is his
Fine,
name?
I will join back again. I'm fine. Trying to find my name. This
Pacify Medical, that is your team.
right, yeah.
Yeah, please join there.
Mugdha, did you just tell Sai Prasad his own company's name?
I did. He seemed lost because so.
Dr. Chintan, do let me know when we have to close the.
Yes, certainly. Let's give people 1 more minute. I think we have 14. I have 13 responses.
Nishant Beriwal, you can join Team Avat. Your teammates are there. Nishant, can you hear me? Yeah, I think he's
Yeah,
gone.
Mugdha, I have transferred.
Good. Just check Anmol if koi bahar hai to you'll have to put them in. Why is Tulsi here? She couldn't find Avat. Tulsi, are you not able to? Okay.
Now I could unmute. Sorry. Yeah.
Yeah. Your team is Team Avat, right? Can you join that?
I went and we came back now.
Oh, you're done. Okay.
Yeah.
Right.
Okay, well, I think we can.
Let's recall them.
We should recall them.
All right. Yes.
And I have a few teams. Maybe we can. Let's see. Let them. Just let me know when they come back.
Yeah, everyone should be.
Everyone's back. Okay. All right. Great. Yeah. Well, thank you so much. I think many of the responses, are looking great. I think what we can do now is that I'll call on a few teams and they can read out their mission statement. And when they read out their mission statement, what we want is we want the rest of the teams listening to it to be the peer reviewers. So if you have any feedback, please raise your hand and I'll call on you, whoever has the feedback. So let's hear from Suture Shore. Can somebody from Suture Shore read their?
Yes, sir. I am there, sir.
Great. Go ahead, Nikhil.
Hello.
Nikhil, can you read your mission statement, please?
Yes, sir. So we are working on an advanced laparoscopic instrument for the surgeons. Hello.
Yeah.
Yeah, go ahead. We can hear you.
Go ahead.
So can you hear me?
Yes,
Yeah.
I can hear you fine.
So we are working on an advanced laparoscopic instrument for the surgeons to provide them wrist-like maneuverability in the laparoscopic surgery.
Okay, great. So any feedback for
to help
Nikhil?
the surgeons with the wrist? Yes, sir.
to help the surgeon with
Wrist-like maneuverability.
Wrist-like maneuverability for surgeons. Okay. Any feedback for Nikhil? His mission statement. What are they doing? For whom and why?
I could not understand something here. He's saying the wrist-like maneuverability is for surgeons or for the patients. I got a little bit. Can you read it again a little bit? Like, so this solution is for the surgeon or for the patient?
Yeah, it is for the surgeons. Basically, it is for the laparoscopic surgeons. So what we are providing is a multifunctional single hand operated device with the wrist-like maneuverability.
So, Nikhil, what does the surgeon gain by having the wrist-like maneuverability? What that they can't do right now?
Yes, sir.
What is it? Do you hear my question? Sorry, I think you're.
Nikhil, please cut off your video. I think your bandwidth is poor.
Bandwidth is low. Yeah, that's good. Yeah. So the question is, Nikhil, that wrist-like maneuverability, what does the surgeon gain by having it? Why does it matter?
Yes, sir.
Yeah.
Sir, because conventionally, when the surgeon operates in an open and cut approach, he has a 36 degrees of freedom. But when it comes to a laparoscopic surgeon, due to the conventional instruments, the 36 degrees of freedom is restricted to just 4 degrees of freedom. And there is a counterintuitive movements that when the surgeon moves hand towards the right, the instrument moves towards the left.
Okay. And so what does your device do that helps the surgeon? I think your mission statement is probably understandable for
Yes, sir.
somebody.
So my device, it has a joystick.
Go ahead.
Hello, can you hear us? Nikhil? Nikhil?
I think we've lost him.
Sorry, I think we should just.
Hello?
Over. Yeah.
Yes, Nikhil.
Yes, sir. So
Yeah.
I'm having a little bit of network issue today due to rain. So yeah.
Okay. No problem. So I think let me just say that I think you want to the why part of your mission statement would be good to make to make it understandable or appreciable for somebody who is not a surgeon.
And I think the company that did a fabulous job with that was Intuitive Surgical.
Okay, sir.
I heard you use the word intuitive, and that was their marketing, was an incredibly expensive robotic surgical system, but to give the surgeon the same dexterity that they would have in open surgery while doing minimally invasive. So the patient achieves those benefits of small incision, but the surgeon can still suture. And that was actually the key, to ease suturing while passing through a single port. So definitely want to look at, that goes back to the prior art. You want to look back at the history and see what was the sales pitch that Intuitive Surgical used to push a $2 million machine. Let's, Chintan, let's grab someone else too.
Yeah.
One more.
Sure. Let's go to how about Lamarck?
Hi, I'm here.
Yeah. Yes, Vaibhav, please.
So our mission is to provide pharma companies with thermostable protein biopharmaceutical formulations which enable them to access markets in pharma emerging nations where cold chain is not intact.
Okay.
I think I wrote that because I was just copying based on the structure that you gave me. I could not see exactly, but it was more or less that, yes.
Ooh. Yeah. Okay.
Yes.
Any thoughts? Anybody? for Vaibhav? Nevin, any thoughts for Vaibhav?
I think there's a little bit of industry knowledge required, which I think just a tiny bit of reading people will have to understand the importance, but I believe all three parts are there.
All three parts are there. Yeah. I mean, I think you can yes, you can dilute it a little bit in the sense, I mean, you can make it understandable to a broader audience, depending upon your audience, maybe investors, etc. You may need to say why this particular technology, what does it do in your sentence. But yeah, all the three parts are there. Do we have time for one more team, or shall we go on? But I think by and large, people get the point as to what the mission statement ought to be. So
yeah. Let's
one
pass
more.
on.
Okay.
One more.
Right.
One more. This is
one
important.
More. Why don't we go with one more? Okay. How about Team Ashita? Somebody from Team Ashita here?
Okay, move on.
Okay. Yes, looks like someone just chimed in.
Good evening. Yes.
Yes.
So my mission statement is to sell a product which is a novel appliance, novel device. So the technology of this device to companies that deal with dental products and equipments, to dental specialists or surgeons who get to correct deficient upper jaw.
Okay. Any feedback for Sandeep?
The why is missing.
So
Yeah. What is the why, Sandeep?
See, why? Because when a patient has a deficient upper jaw, actually I have one on the chair now. When a patient has a deficient upper jaw, so the patient cannot speak properly, speech is compromised, and mastication is also compromised, and obviously the overall looks also is compromised.
And you said what? So what is your activity? You said your activity is to sell.
It's a B2B business, so I sell the technology to a company like a 3M or an Omco. So I sell it to the company, so they already have a network of specialists or doctors, and they in turn will sell it to them, because the present products that are present in the products that are present in the market as of now are big, extraoral and bulky, whereas my product is small, compact and intraoral.
Okay, but but what is it? Is this a product you have developed or you are buying?
I have a patent, and I only have developed it. As of now, I have done it with 3D printing, but I want to move ahead and do it with injection molding.
So the selling is so what problem is your product solving? Is the what part of this, right? The selling, of course, all of you will have to sell.
Okay. So you mean to say in the perspective of patient or for the company?
From the perspective of the end user.
End user is the company. So end user is the patient. So the patient has a small upper jaw. The patient has a small upper jaw. So that is not good. So even aesthetic wise, one is not good. And speech is compromised. Even the mastication is compromised. So with my product, it is a patient friendly product. So patient gets to use it very nicely. The patient can remove it as and when they want. And the correction is done in a shorter period of time with more efficiency.
Right. So So I think that's where you want to center your mission statement, that you want to say that you have built XYZ.
Okay.
So that certain type of patients certain type of patients will find a certain improved condition. That's one way to go about it. Or you have come up with XYZ.
Okay.
So a certain type of doctors can perform certain type of procedures better, whichever of the two.
No, that's the reason I mentioned it as specialists/doctors.
Right. But focus on your solution rather than say your goal is to sell. is not the mission statement of your company, because every company will have that mission. No? So I think your solution, center it on your solution is the point. Yeah. Ramji was trying to chime in between. Ramji, were you trying to say something?
No, I mean, just want to say the same thing. You know, the mission statement cannot be saying the sell. He started with the word sell. I think, you know, he need to change that. Thanks.
Yeah. Yeah. Okay. Okay. Good. Okay. Let's move on. Nevin, let's go to.
Absolutely.
And by the way,
And
all of you, just let me just say one more thing. All of the, please take this, all of this constructive criticism in a stride where we're just trying to improve things from where they are. Okay. So,
Definitely. Yes, sir. Thank you.
An important intercultural learning Chintan and I had once is we learned that you should never use the word criticism when you're teaching a workshop in China, because that word has a very bad history. So we always want to talk about it as group feedback, group support. Make sure that it's this is a safe space. Today we can happily tear apart and help each other rebuild ideas. That's the idea. And I also want to add that for healthcare technology, because I think 50% of the groups here have a healthcare technology, it's extra difficult because in a B2B product, it's pretty clear usually who you're selling to. In a B2C product, it's clear. In a healthcare product, you are selling to often 3 to 4 different parties. And so encapsulating all of that is hard. You have to, first, it has to have a benefit for a patient, otherwise you shouldn't be doing it. It has to be sold to the clinician who is the one either prescribing it or using it. And then it often has to be sold to the people who are paying. In the US, we have, the patient is not always the payer, so they will have a say in it. And there may be a regulatory group that you also have to convince it's a good idea. So the multi-point customer profile is really hard in healthcare. We could even do a separate session to discuss that just as kind of a group on another day. But jumping ahead, we want to take that mission statement. We know what we're doing. We've talked to our customers. We've talked with them about what are the functions they need specifically in order to achieve that mission. So if we want to offer the patient or the physician a tool that will allow them to treat the patient quicker, more comfortably, and for a lower cost, those are being the results. Those are essentially the metrics that you will evaluate your own product against. What are the main functions this device needs to do? So we always talk about function requirements rather than product features. In the case of our mouse elimination example, well, it seems that there's probably 4 things that are necessary if we're going to have a successful way to get rid of the mice that are living in the walls. We have to obviously find the mice, locate where they are, do something that makes the mouse go away, either voluntarily or involuntarily. It needs to be clean because homeowners really don't want to deal with, let's say, the aftermath of the traditional snap traps. And it has to be safe. So you have to be something that dogs and cats and small children will not, and frankly, large children, myself included, I'm pretty uncoordinated on a daily basis, that won't hurt them. Now you notice that we haven't described the product in any special way here. We've described what the product needs to do. And to help with that, my boss, my buddy, Alex Slocum, uses this kind of design method, which takes people through. And this is a tool. He calls it the Fred Park sheet. It's just a fun acronym, but it's where we talk about step by step, what is it we need to accomplish? And if we think about it first, obviously, there are some requirements. You can't see the slides. Someone should tell me this. Okay, one sec. The share may have broken. I can fix that. Not a problem. Thank you for the heads up. It apparently broke during the breakout rooms. That's embarrassing. Okay, slides are back. So we'll just back up a slide. We think about our main functional requirements. We keep them broad. We don't constrain ourselves at this stage. Moving forward, we then use this chart that Alex called the Fred Park, where we just outline kind of the main requirements. We put them here first. I'll get my little pencil. Here we go. I did not do what I thought it would do. That's always embarrassing. There we are. We start by transferring the requirements here. And then against each requirement, we need to put some sort of parameter. So something that adds detail. Again, we're not talking about the exact feature. We don't say it needs to have a switch or it needs to have a screen. No, it needs to communicate with the user and allow the user to interface. That's broad. Whatever then we put down here, it adds detail. So we'll talk about that in the next slide. And then as we go forward in the process, you want to add the analysis. So the analysis is coupled, of course, to the references. So we talked about looking at literature. If you need more information that informs your parameters, you need to find that information somewhere. And then always think about what could go wrong. How can we mitigate that risk? So those are the kind of steps. And this is a tool that we use. We can use it as we create strategies. We can use it as we go into the detailed concept designs and just keep updating it. It's a living tool, but it also provides the beginning of what we call, especially in the healthcare industry, the design history file. So it's one thing to have a great idea. It's another thing to turn it into a product. What separates the idea from the product is how well you follow the process, how well you document it. So with that, let's clear and jump to the next slide. Design parameters add a lot of details. So in the case of our little mouse, we want to talk about how big is the mouse? If we want to find the mouse maybe with a thermal camera, we start having ideas. Well, what is a thermal signature? Well, what noises can mice hear? Maybe we want to repel the mice. So you can see how the ideas we're generating are not super specific. They're general, they're broad, they're based in physics, but they get us started. And we want to add details about materials and weights, and if it's an electromechanical product, what's its duty cycle? How will the user communicate with the product? And also, we often talk about we want to make our product affordable. We want to make it low cost. Well, great. Affordable for who? Is it for what percentile of income group? And then if we can find out what their average income is, then we actually need to put a number. So not just to say we make the product affordable to low-income users or middle-income users, actually put a number so we have something to drive our costs and bake that in early in the design process. And this is just an example. Well, if we're trying to catch some small animal and do something about it, we kind of need to know how big it is and how much it weighs. So, and of course, we always put our reference down. So if it turns out we made a mistake, we can go backwards. So with that, we're going to send you back to your rooms. Maybe we'll do it automatically. If that works, great. If not, we'll ask you to manually find your way to your rooms. But we want you to write down 4 or 5 broad functions and put any additional information. Chintan?
Yes, and here is the link for doing that.
Yeah.
So functional requirements and design parameters for meeting your mission. Okay, let's take maybe 3 minutes more.
Okay.
Anmol, before you call people back, we'll just do a quick check because this may come maybe just finishing up and so on.
Okay.
I'm not seeing any responses just yet.
I checked on a group and we were quite busy.
Yeah. And I saw, we got 18 responses for the mission statement. So that's the
great,
maybe the upper limit.
Anmol, you want to broadcast a message? Please submit your responses or something.
Give them time. The group I checked in was putting down 3 functional requirements and busy adding detail.
Okay. All right.
We can all pop into different breakout rooms. That's what I'm doing. Chintan? Let's give them another.
I had gone to, sorry, I had gone to a meeting room and they were also still working through. So I think, how many, let me see. I have some 10 responses. So let's, Anmol, let's call them back in a minute.
Okay. Okay.
Nevan, it might help to provide a example for the against the functional requirements. When you're asking for specific numbers or anything like that.
Yeah, that's true. It varies per each product. If we have a lot more time, we can go into that. I think today it's a little tight for us to dig down.
In the mousetrap, what would be an example? You can try maybe one.
Sure. If you have a strategy that, we'll get to strategy in the next 2 minutes, that you'd like to repel the mice instead of catching them, so convince them they should leave. Actually, I'll use an example. This is a great question. So I'll use an example of a real product. So there's a product that's called the Teenager Repellent. It's for businesses that are suffering from teenagers arriving and sitting outside and using skateboards and vandalizing things. So they developed a sonic teenager repeller, and the key piece of information was if you're over about 20 years of age, you can't hear the frequencies. So they had to look at the research and understand what were the frequencies that teenagers could hear that adults could not. And then they developed a transmitter that put out those high frequencies. It's a real product. I can look it up, drop it in the chat. I'll put it out.
Okay.
It's kind of fun. It's a good example. It's because it's very simple. That's all they had to do is get the frequency right.
So I think, but Nevan, don't we had one slide which is just for the mousetrap, which says, okay, detect. Okay,
we do.
Oh, I see. We will go with its parameters once we talk about the strategy. Okay.
Yeah.
Yeah, sounds good. Okay, we have a few responses that have come through. Okay, I think we should call people back and then.
So Nevan, the example that you mentioned just now, so would you say that the functional requirement is repel less than 20-year-olds?
Correct.
Right? And a design parameter would refer to a solution, say sound with a frequency X to Y or something like that?
Exactly, you've got it.
Okay, so
let's make sure we use that example. Is everybody back yet? Because we can use that as a good example.
Yeah, everyone should be back in the main room.
Okay, fantastic. I'll make sure screen is still sharing. Boop. Share is back. All right, so everybody's back, I hope. We had a good question of give a concrete example. So if I remember correctly, there's a product that was released in the United Kingdom called the Mosquito. And if we've decided, and this will come as we think about strategies, these design parameters are a changing field as we go forward. The Mosquito product was designed to prevent teenagers from loitering outside of businesses because they were annoying owners and scaring off customers. And they decided that the best way they could get rid of them, obviously a sign doesn't work, was to use a high frequency sound. And that sound had to be heard by only teenagers. So they did research. They were able to figure out what was the loss of frequency response as people grow older. And humans can hear between, I believe, 20 hertz and 20 kilohertz. So we have an amazing wide range of hearing. So they went to the top end of that and then figured out around about age 20 or 22, what were the frequencies that you started losing the ability to hear, and designed a transmitter for just those frequencies. So that was a specific requirement, was, repel the teenagers with sound, and then the design parameter became what were the frequencies that were acceptable, and also what were the pressure ranges, because you still don't want to put out a sound that's too loud, too many decibels, even if most people can't hear it, that it would cause teenager hearing loss. So the second functional requirement became safety. So the safety would feed into the decibel requirement, whereas the repelling feeds into the frequency requirement.
Yeah.
Or parameter, I should say. So that's an example. So if we jump forward, Chintan.
So yes. So I think let's hear from a few, and again use the same technique. One, while somebody presents, everybody else is a reviewer. So how about we go to nuclei trace? Am I pronouncing the name right? Somebody from
Anmol, which team is that?
Is that nuclei trace? That is, they've filled out nice requirements here.
I think that is Shubhadeep Bodhak.
Okay.
Shubhadeep, are you here?
There was a request, if possible, the response screen to be shared.
Probably Somnath Roy, right?
Oh, I can't unmute, Shubhadeep is saying.
Yeah.
Okay, fine.
Yeah, that's fine.
Okay, we're not able to unmute. Is that because of some Zoom issue?
Yeah. How about now? Please
Hello?
try.
Yeah, I'm Somnath. Yeah.
Yeah, go ahead, please.
So, Somnath, 1 minute. Just could you say what your mission statement is first, and then go into your functional requirements as you see them, please?
Sorry, actually, I am joining from mobile since I am out of my desk. So I requested my team member Sandeep to jot it down. So I don't exactly remember word by word.
Okay, no worries, no worries. Fine. So let's go to somebody else then.
Sandeep, can you please help?
So, shall I unmute Sandeep Rao?
Yes, please. I'm here to defend all the points.
Yeah, now I could unmute myself.
Okay, great.
So our mission is to provide rapid, sensitive, and cost-effective COVID-19 diagnostic tool airport, because the current tools are either costly or time-consuming. So this was a mission statement, and so what I have currently drafted is about detect. So the similar device has been used to detect the bacterial DNA. This device is developed by Dr. Somnath Roy. So it has a sensitivity up to 10 picomole. So that's the first point we said, that it's ultra sensitive with 10 picomole load of detection sensitivity. Second is about the portability. It's 3.5 inches by half inches thickness. So it is ultra portable, and that will add to a value. Third point was safe. So it does not require power supply or battery. So it's drive the energy from mobile phone to which it is attached for interface. So that's clean. That add one more point. Another, as it is easy interface, it's a mobile connected interface. So it does not require a specialized manpower or a skilled manpower. So that's one additional point. And fifth point I'm missing because we have submitted it.
Yes.
Dr. Chintan, can you?
Yes. So it says it does not require high-end lab infrastructure.
Yes. So currently, the Abbott ID now, which is a strong competitor, which is ultra sensitive and time effective alternative, but the machine cost and the test cost is at the higher end, and the infrastructure required to utilize that equipment is also very sophisticated. Whereas for this device, only RNA isolation is the single tricky part. Otherwise, this equipment do not require higher end sophisticated lab facilities.
Okay, so I think your piece, of course, is very it is very advanced in terms of you already have an artifact. It sounds like, right?
Yeah.
You have this device. Okay.
Yes,
So
I have the prototype.
you have a prototype. Okay.
Yes.
So and
yes.
so if one were to sort of map this what was just said into the functional requirements and design parameters, so one would say it needs to be ultra sensitive. In this case, your design parameter is 10 parts.
10 picomoles.
10 picomoles. Sorry.
Picomoles, yes.
So that was the measure. It needs to be compact. So there is a certain size requirement that you put out there. It needs to be user friendly. So in terms of the interface, it needs to not require power supply or battery for the green niche. It needs to be green. So
yeah.
The design parameter there is that elimination of the power supply or the battery. And then finally, it needs to be independent of this lab-based infrastructure. So these are kind of the requirements, and then some measure by which you will measure that requirement. Now, obviously, when you came up with this, so one question: how did you come up with this list?
How, in which sense?
In the sense, why these 5?
Okay, so as we know, in certain resource-starving situations, like in airport or in a remote place, on mountains or so on, where you do not have the sophisticated laboratory like our northeastern part of India and some of far remote villages. So you can just carry this thing in your pocket, and I mean, just on a desk, you can set up, and you can keep on doing the test.
Okay, I see. So that was the use case, and based on which you derived these functional requirements.
Right.
And there's some measure of it. Okay, excellent, excellent. That's great. Okay, shall we hear from one more? Sorry, is there any feedback for this team from anybody?
Chintan, I just had a point that they have listed the points, but they might need to see what is missing, right? For example, it's an airport application for diagnostics, so specificity becomes important, speed to result becomes important, so on. So I'm just, those are points, but they had listed some others, right?
I think in the mission statement, Dr. Premnath, we tried to cover that. Rapid, then a cost sensitive.
So that will come in their functional requirements also. That was what I'm just trying to say, because
great. We'll modify accordingly.
Well, you made a good point, because the function is a sensitive test, and as you layer this, you start adding the detail. So in the end, you have your functional requirements, your design parameters becomes a very detailed specifications document, and then you can test against those. So if you have a specific target sensitivity and specificity, then that goes right into your documentation. And when you build your test, you take a look at it and you evaluate it against those metrics. Likewise, for the user interface, if you say that it has to be a straightforward cell phone based interface, you've decided on that, then you can actually do user testing to find out how long does it take. You create the manual, or you perhaps you have it all built on the cell phone app, so the manual is digital. How long does it take a person to learn it? What are their errors? And in fact, if you ever go for US FDA approval, and there's a human component in the technology, which pretty much all healthcare technology has, in fact, most products do, you'll actually be required to do that human factors testing. So then you can start looking at, as you put in your analysis and your references, start looking at the appropriate standards, the appropriate tests that you will use to evaluate your own product. If it's purely a consumer play, you can still use those standards, because you can look at user adoption to conduct user focus groups. Maybe that's your form of testing rather than sensitivity and specificity, but you still want to do that testing to evaluate.
And also, and also CLIA waiver kind of stuff.
Yep. So there's a ton of wonderful detail that can grow. Chintan.
Yeah, so I think there was one more question from the YouTube coming through as to how you identify risk and assign the probabilities to these risks while doing device development. So I think we'll come to the idea of risk a little later on when we talk about the most module. But I think to Premnath's question and the subsequent discussion, I think these functional requirements, one of the things that you want to see is that are they underspecified? So have you specified them all is an important point. Let's go to one more team. Shall we go to Ayur AI? I was in that room for a bit. So please say what your mission statement is and what your functional requirements and design parameters could be. Was there a request that I share the people's responses so that they can?
Yeah, I think that's a good idea, because I think once they type it out, they might have lost the, unless they've kept separate notes.
Yeah, that's right. That's right.
I jotted down something simultaneously, but
yeah. No, so okay, let me do. Bala, are you okay, or shall I share it? We can.
I'm okay. I noted
down. Okay, go ahead.
Yeah, so I'll just first read out mission statement so it's clear.
Yeah.
Our mission is to provide an AI integrated app for Ayurveda doctors, which is faster, accurate, and convenient way to diagnose diseases and also suggest therapeutic interventions.
Okay. And
so the functional requirements, thanks Chintan for your help also, Chintan for your help also. So we've listed a couple of them. First, you should be able to collect patient data using conversational AI. That's functional requirement. And the design for that, design specs are, we should be able to, the question, it's a conversational AI. So it keeps on asking questions till a certain accuracy of the assessment is reached.
Okay.
So we have put, 90% accuracy assessment is reached, so that the questionnaire stops after a certain time. Second is have an inbuilt Ayurveda database. So essentially, it would be collection of database from multiple texts, sources, papers, clinical trials, etc. Third is analyze collected data from multiple sources. So essentially, this is from patient symptoms, patient blood tests, if they have a blood test. So the design requirement here is should be able to diagnose the disease with greater than 90% accuracy, and suggest in the decreasing order of the probability what the AI thinks the disease is as per the Ayurveda framework. And the last one is suggest interventions. So essentially, the design requirement is suggest 3 to 4 possible drugs which can potentially cure the disease. Again, using the data collected from previous patients, papers, knowledge base, etc.
Okay, great. Any thoughts for Bala?
Some functional requirements, did they sound a little like activities rather than functional requirements?
Which
Bala?
ones, Premnath?
Like they should do this kind of a thing, which you were, when you're saying that it needs to do specifically, collect data from texts and put it there and all of that. That's sort of activities you need to do at the back end of your product, right? But functional requirement is your accuracy, which you mentioned, right?
Diagnose the disease, that's functional requirement.
Yeah. Also, you might want to think about one of the things is you're making it a little more objective. You're reducing variability between different physicians, right? Those kind of things which you're bringing to the table, right? You're bringing in modern biochemical metrics in, which basically means that your input data set is more varied. So in that sense, the functional requirement has to do with giving a more complete assessment, right? So I'm sorry, I'm struggling for words right now, but I just thought you missed out some things here.
Sure. So an integrative assessment we can add,
That actually could become part of your mission statement. The integrative assessment is, we have a term, we talk about integrated medicine.
Yeah, sure.
That might actually be what you're trying to do, is to bring the more traditional knowledge to bear, so it doesn't have to operate in conflict with the more Western clinical medicine.
Sure.
And we should probably move on from this, but I think you both of you could have a really fascinating discussion offline. I'm happy to be part of that too.
Thanks for the suggestions and feedback.
Great. All right. So let's march along. Nevan, and I will put the responses. So here's a question, Premnath. This is probably a question for your team. Can I put a consolidated document that has everybody's response for in the chat? Is it okay with the intellectual property type of consents?
Yeah, we are keeping it all non-confidential, and also it can go in the classroom, which Anmol is maintaining.
We should do that then.
Yeah.
Okay.
All right, Chintan, do we do one more or should we keep going?
I think we should keep going.
Okay, do we need to give people a 2-minute refill your coffee cup break? Does anybody require a break, or do we just keep rolling on?
I think a 2-minute break would be good. It's 6:27 right now. So yeah, maybe about 6:30.
6:30. We'll be back at 6.
Yes, thank you.
So it's a 3-minute break. Excellent. I will do the same, refill my coffee cup.
I think we should probably continue now.
Okay, people are back?
Yep.
Excellent. I am too. Fresh coffee. Not so fresh, actually. Should have made it hot. All right, anyhow, so once we have our functional requirements, and people are already jumping ahead, which is fantastic. That's how it's supposed to happen. We want to talk about strategies. And strategies are the broad ways we can address this challenge, the broad ways we could meet these functional requirements. It's not about quickly starting to draw the design, although it's fantastic if you start sketching it. But we don't want to fall into that trap of CAD-itis, where we are busily making detailed CAD models. The idea is to keep it broad so that we do make sure we've really explored the solution space. And we can do that from the physics standpoint. You'll take, for example, a test for a medical condition. What are the different methods? Are we going with a biochemical assay? Are we going to look at cells? What are we going to do? We can look at a couple of broad ways. So if we continue with the example of the poor little mouse that's hiding in the house, well, the most obvious way you can get rid of your mouse problem is you can kill them. And we can evaluate that as an independent strategy. The second most obvious way is to capture them. So we can catch them and be a little kinder and redeposit them in a different location, in the nearby field, in our neighbor's house. If we don't like the neighbor, we can do different things. Or we can also convince them voluntarily that it would like to leave. And so those are kind of three main strategies. They're funny, but the idea is they're all separate. We can combine them later if we want, but none of them are exact designs. They're all big goals, but all of them may or may not meet the functional requirements. So let's say we just rule out kill initially, but we want to validate that we can rule that out because we're kind. We don't really wish ill on them. They're small, they're fuzzy. How can we start picking our strategy? So one tool that we found useful, I've used it myself, is a pew chart. And it should be familiar to most people, but if not, a little primer is you just take your three main strategies or your three main concepts or whatever the main options are that you're trying to decide for, and you put the metrics down on the y-axis. So obviously in this case, we've just taken our functional requirements, we put in our detecting, our somehow deal with the mouse, the need for it to be clean, the need for it to be safe. And actually we've added an additional metric, which is the complexity score. And let's say we're already not happy with killing them. We need to set a baseline. So in this case, what we do is we set capture as the baseline and we just assume we compare everything to capture. And there's multiple ways to do this, but this is just the most straightforward. And then we just ask ourselves, well, in terms of eliminating the problem, is killing the mouse better, worse? Gets the job done. Is repelling the mouse better, worse? Gets the job done. But is it clean? Let's look at the clean requirement. Well, certainly capturing the mice, it's a little bit annoying, but it's not as messy as killing them. So killing the mouse, we assign -1 to that because that's going to create a mess. We got to clean that up. But capturing isn't great either because you have to deal with a box with an angry mouse inside of it. It doesn't really pose you a lot of danger, but it's not fun walking around with a box of angry mice. Whereas if we can repel them, we can assign a +1 because, well, the mouse has decided to leave voluntarily. It's packed its bags and gone. So we don't really have any mess to deal with. It's pretty darn clean. So we give that a +1. And at the end, what you do is you start summing it up and you can see a score. And the idea is not to become slavishly bound to getting the numbers perfect. That's why in this case, I just use +, -1 or 0. It's more of to just get an understanding, discuss the options with your teammates and come up with a general conclusion. In this case, killing really just isn't satisfactory. It doesn't sufficiently meet our functional requirements. Capturing is the status quo, whereas repelling, well, that seems to garner some benefit. We've got a +1 score on there. So let's see if that's the strategy that we can proceed with. So bearing that in mind, we jump forward to taking a look at what is what's an actual concept? Well, the concept is your specific design. Now we start adding that detail. We look at the actual mechanisms. We might think through the electronics. We start thinking about power budgets. We start building the actual system, or at least sketching out what would our prototype look like. And that's where I think the pad and paper and the crayons comes in really well. And if we've decided that we want to repel the mouse, well, what could we do? Well, we could do some sort of strategy of capturing it or detecting it, attracting it, detecting it, and then vacuuming it. So the idea is, of course, you'll locate the mouse and somehow pull it into a system, and then that's the capture strategy. Well, that's not great. But we started to look at strategy number 3, which was the repelling the mouse, and then we started drawing up that concept, and it looks a little more interesting, a little more promising, because we go back to that Pew chart where we've said, well, we're not a fan. Capturing it is okay, but not great. Well, what if we can use some sort of thermal detection, some sort of ultrasonic array, and actually just find the mouse, convince the mouse to leave? So we've basically got an anti-mouse ray gun, which sounds like science fiction, but it's actually doable from a physics perspective if we want to do it. Mice have thermal signatures. We can determine how much heat a mouse puts out. So again, we're thinking about our references and our analysis that we have to do. We can certainly figure out what frequencies mice don't like and aim those frequencies at them. We can get that from literature. We can get that from testing. But there's an actual path to this. So essentially we've ruled out strategy number 1, which is kill the mouse. We've taken a look at strategy number 2 and strategy number 3. And for both of those, we've drawn up a specific concept. And you can draw multiple concepts per strategy, but really this is it's a tool to help us stay broad and then narrow in our thinking so that we can say to someone, yes, we have looked at the market space, we've looked at the design space, and we've got an actual concept when we're done that we're pretty confident is interesting and will work. And so with that, because we're taking you through the express course, we want to ask you to take a look at your functional requirements again, revisit them, and hopefully what some teams have been doing is they're keeping a Word document on the side and they're just writing this down and then pasting from the Word document into the survey. And I think one of the ideas Chintan and I have had is going forward, it would be nice to have a digital tool where we can do this and allow teams to capture this information better. So that's on our list of interesting projects to work on when we have spare time, which is none of us have enough of it. But we want you to write down, look at your functional requirements, write down 2, maybe 3 strategies. How could you achieve this? Pick your favorite. Use a Pew chart, don't use a Pew chart, whatever you're feeling like. And then for that favorite one, sketch at least 2 potential concepts. Just write them down. Pick one if you can, if it's possible to take a cell phone picture, or just hold it up to your computer and take a picture on the laptop camera and upload that so we have those. And we're going to give you about 15 minutes to think through this. We will have you report out not after this, but after the next step. So keep a record, please, of what you're doing. But let me pause for a moment and ask if there are questions before we send people to their rooms, because we're moving quickly and we accelerate the pace as we go through this material. Put them in the chat or just unmute and yell at us. We like questions.
And I put something in the chat, 3 or 4 strategies and concepts. So that's where you can fill that out.
Yeah, I think I have a question. So if we didn't get our functional requirements right, for example, in our case, we were a bit confused because the component, Harish, are you there? Maybe Harish left here.
Oops.
Yeah, basically we are trying to develop a 5G. Can you hear me?
Of course.
Yeah, okay. We are developing a 5G components for the 5G base stations. Okay. So what we have put is the kind of the functional requirements as the power, frequency, and then the design parameters, we put it as the the thickness of the film. So that is what, whereas I understood after listening to you again, that you want those to be measurable, right? The design parameters.
The design parameters should have numbers because later you can look and see if you met your numbers. And
Okay.
your product may be very detailed, a very specific application. So your level of granularity at this stage may be much higher than, say, someone who is making mousetraps or trying to make a brand new consumer product. So that's okay.
Okay. So can we do it in multiple stages is what you're saying, Nevan?
Mm-hmm.
Okay.
Yes.
So, okay.
This whole process is iterative. So have at it as many times as you'd like.
No, I'm trying to understand at a very conceptual level when you say that functional requirements and design parameters. What we thought is functional requirements is what do we get as specs from the customer? Is that right? That's what they need, right?
The specs may be closer to design parameters. We can use those interchangeably. I think the idea of the functional requirements are keeping it just a little broader. What is the customer trying to accomplish with this product?
Okay.
Is it we want to have a low power transmitter, and then you can identify what is that low power. And I think it's the reason we force this a little bit is as engineers, I'm an engineer, Chintan's an engineer. It's very easy for us to get stuck really quickly down in all those detailed specifications and kind of miss that first question of, well, why are we doing this? Because as entrepreneurs, we have to always be selling our idea.
Okay.
Does that kind of make sense?
Yeah, I think, yeah, it makes sense, but maybe our understanding improves over time. So
yeah, I think Tulsi, the radio heads need to have meet certain requirements to do better than what is available, right? Those are the functional requirements, and then how to do it, those are details. Those will be probably based on concepts, right?
Okay.
In sense, thickness of films or material changes or whatever, those will not come as functional requirements, right?
Those are your
Functional
specs.
Yeah.
And also, if your requirement is something along the lines of improve efficiency, then you can certainly benchmark competing products and look at their power efficiencies. And then you made it, I say, better thermal management than the competition. Okay, then you can start looking at what are the different ways you could achieve that better thermal management, if that's one becomes your key special sauce. And there's a bunch of ways you can do heat sinking, you can do fans, you can do more passive cooling, but there's a lot of strategies that could pop up. So you have to scale these. These are only tools, and you have to make the tools work for you. Don't be forced into the tools. That's not a good way that we don't want anybody to feel that this is it. This is the process. You don't follow that, you are excommunicated.
Okay. We'll try. Yeah. Thanks.
It's all about just making sure you broaden your thinking a little bit. So let's say thermal, I'm guessing thermal matters to you. Am I correct?
Yeah, that is one of the parameters.
Yeah, that's one of the, yeah.
Yeah. So the idea of this process is just to get you to consider, if you aren't having a creative day and you start designing the details of a heat sink and you miss a bunch of other cooling options, we want you to just not miss those others and consider them. And also, if they're not appropriate, discard them. But by recording how you made that decision, we looked at 6 different ways to keep this thing cool, and we've discarded 4 of them. You now have a design record. It also deals with the special people later who come back, who think that they know your business better than you do and ask, well, why didn't you do X, Y, and Z? Well, we've considered that. And in fact, this is why we ruled it out. So it becomes also a defense mechanism. I've been there. I've been in investor pitches, and you get these investors who think they know more about engineering because they have sold one successful company in some completely different field, and they start just throwing ideas at you, and you will be better prepared to defend yourself.
Yeah, sure. Thanks for those inputs. Yeah.
Happy to have offline discussions too. So let's give Chintan, have we sent them to their rooms, or are they headed to their rooms?
They should be heading to their rooms now. They are all in the rooms.
Anmol, I sent you the filled out forms of people for the first and the second exercise.
Yes. I'll make them available on the Google Classroom post session.
I will also we can try one more experiment. I will post for everybody the link where the third exercise will keep getting populated as people submit. So
okay. Dr. Chintan, the link you shared, it asks for access.
oh, it does. I see. Let me see. Okay, let me go and. This is the, are you're referring to the filled out link, right? Or the link to fill?
The filled out link, the sheet, Google sheet, yeah.
Yeah, change permission. How do I change it? That's a tricky thing. Okay. People added can open this. People added. I see. Change. Okay, now we should try.
Yes, it is working now.
Yeah.
And I think the same for the first two responses as well. I wasn't able to access those.
I see. Okay. Okay, now you can try the other two also.
Yeah, I'm able to see everything now.
So I'm going to hop into one of the rooms and then come back.
Yes.
I have no responses yet. I wonder how people are doing. Step into some other team. I was in another room. There was some confusion. So I don't know. Nevin, have you been to any of the rooms yet?
Yeah, I was sidetracked in a room that was asking some very interesting questions about what goes into a pitch deck and how do you share what you're doing without giving away your IP.
Yeah.
So that's we're scheduling an offline discussion because they're at a point where we need to talk privately.
Yeah. Okay. So I think there's with this idea, I think one of the things that you may want to talk about is, many of these teams already have their solutions. And so for them to step back to thinking about strategies even more, step back and say, okay, can I broadly brainstorm strategies? Is I think something that this is the opportunity to do that. You may find modalities of your of a solution that you may not have considered before.
And I've got a great question that came through, about how do we do risk assessment?
Yeah.
So maybe we should also, we should give them the concept of TRL from NASA.
Right, unless it's coming through some other session. But, so we have 25 minutes now.
We're good. We're on time.
Yeah, we want to keep some time for them to ask questions, right?
Yeah, and we can stay later. I'm free to stay later. If people want to stay, hang on and talk, I'll stay until they're done.
Yeah.
Yeah, are people back? Should we pull them back from their rooms? We need to.
I think we need to pull them back. We have about 6 responses so far.
Yep, that's as many as we're going to get.
I think so. I think the number is slowly going down because it gets a little more involved as we go along. Anmol, shall we call them back?
Yeah, so close the rooms. Everyone should be back in about 5 seconds or so.
All right. Okay, so I think looks like there has been some good bit of effort going on. I'm seeing some responses here. And now I also in the chat room put a link through which you yourself can see your responses. So I have some 6 responses. And why don't we hear from
well, Chintan, let's push this until we reach most critical module. Then we'll do a feedback in general.
Oh, fine.
Because the NPM goes with this. So that's why we're on time.
Sounds good.
Well,
so
we had a really good question come through. Seems to have came through on the YouTube, which is how do we do a risk assessment at the early stages? And that's actually a really good question because there is a tendency, unhelpfully, to do at the end start creating your risk documents. But the challenge there is you'll find out potentially that you have way too much risk in your design. So as you make each design decision, not only do you want to keep a record as to we selected blue LEDs because they transmit light better through tissue versus red LEDs, which will start reporting on hemoglobin. You need to keep a record of that, but then also think what could go wrong. So what if the wavelength of and as we just piece by piece, what if the wavelength of our LED is not stable and we're using the LEDs in a sensing application? What can we do about that? Well, the countermeasure to that would be we do a calibration or we do binning. Binning, well, which is more expensive? Binning is more expensive. We test each batch of LEDs and we find the ones that meet the wavelength specification, or we just calibrate our system. Well, that will be cheaper. So that's how we just piece by piece go through the risk. So as each design decision is made, rather than wait to the end, record the design decision, record the rationale, and ask yourself, what could go wrong with this? And that's how you start building your risk document, and you just keep this running list of risk. And it gets kind of scary, but it's a lot better to do that up front because you can start checking off those risks, creating those countermeasures. If we go back to this chart, which I should still be sharing, I hope. Let's make sure I am. There. We really want to keep those risks front and center right at the get-go. And as this chart becomes more and more detailed, always keep jotting down the risks, because then you're de-risking as you go rather than de-risking at the end. Let me clear those and go forward. So now we want to talk actually a little bit more about risk. So that's actually a very good segue. So when you're developing a product, if we revisit this chart, we talked about modularizing in most critical module. Time, money is limited at the early stage of the startup. Startup is always looking to what will get them to the next funding cycle. What's that proof that the investors will need? Well, the proof the investors will need is that your technology works. That's presuming you're building a technology product. You're not just trying to sell something that's purely based on marketing. And if you are, well, that's less interesting. But it seems like everybody in this group is working on a hard tech, a meaningful tech. That's where you basically have to identify what's your most critical module. Critical meaning if it does not work, you do not have a product. So whatever your concept is, there is usually one piece of that concept that is the fundamental piece. And that's really going to have the key analysis step. So if I take a look at the mouse, repellent gun. So let's say we actually have two modules. We have one which is the detecting the mice inside the wall. So we have some sort of thermal camera, and it has a certain sort of sensitivity. And that sensitivity will drop off as the wall thickness increases. So that's probably critical module number one. And with special permission, you're allowed to have critical module number two. Critical module number two is actually very similar. It's once you've aimed your thermal ray gun and you found where the mice probably are, and you then deliver to them ultrasonic energy focused, well, same thing. What's the transmissivity through the wall? What are those frequencies? How does the wall cause a frequency shift, or does it simply just cause an amplitude decrease? You just need to be able to answer those questions. So you want to do that key analysis and think about what's the one piece of your tech. Does it really matter at the early stage if the handle is blue or pink? Not particularly. You can do a customer survey later to figure out which color your customers prefer. But it does matter that the key module that senses and then also delivers a focused energy to greatly annoy that mouse and make that mouse decide that he or she would like to vacate your property, that actually works. Well, what could go wrong? What if we move from New England to India? India, the walls are plaster and cement. Will it still work? There's a key risk. You may find out your product is only going to work in New England, only works on wooden framed hollow walled buildings. Fine, you need to know that, and you need to then aim your marketing towards that marketing segment. So a lot of detail starts coming out as you start thinking about risks. What if a small child gets your anti-mouse ray gun and decides to aim it at his or her sister? So the 3-year-old decides to aim the anti-mouse ray gun at the 4-year-old. What happens? Are you going to be able to detect that it's aimed at something that is not intended? Will the heat signature be too much and the gun knows it's not mice, it might be human, and just shut off? What if they want to aim it at the cat? So there becomes a lot of detail. What sounds like a simple product, just a little thermal camera and a frequency emitter, suddenly starts having a lot of risk. And we want to think about that early on. And then, of course, just keep filling out this chart and adding more detail. Well, if you aim your ray gun at humans, we've got to make sure, in this case, if you're using sound, we have to make sure we stay outside the human's audible range. Well, if a baby were to show up, what do? Well, we need to know somehow that this is not aimed at a mouse, that it's aimed at a baby, turn the system off. And so pretty much everybody's chart should always have a safety or a misuse column. We want to think about in what ways could this product be used incorrectly or pose a risk to humans. So that's where we start filling this out. We may need references. We may have to put in here occupational health and safety standards, something related to hearing ranges. Again, we go back to that prior art, to that literature. So what we want to say, though, is this most critical module, this is it. This is your biggest risk, not only in terms of risk to the user, but really in terms of risk to your company. So identifying what's your most critical technology, what are the metrics by which you're going to evaluate it, that's the crux. So we want to give people, probably we said 10 minutes, we're going to give them 5 minutes.
5 minutes, yeah.
And ask you to just identify your most critical module and what is the biggest risk. Just one big risk that could cause that module and by consequence your entire company to fail. And give you 5 minutes, and then we'll do a little reporting out before we kind of close this session. We know this is short. We wish we had more time. We could talk offline. So if anybody's frustrated this is going too quickly, well, we'll continue the discussion.
So here's in the chat, I put 4 of 4 MCM. So that's the one you can fill out. I will also put a link so that you can see your responses.
Well, I've perfectly demonstrated the risk of a user error. They put the leave meeting button right next to the leave room button.
Okay.
I've definitely made that mistake.
Oh, yes. And that's actually classic. So if you were to do enough user testing, you'd find out that you probably should have a confirm box. Are you sure you want to leave the meeting? Rather than just leaving it instantly.
I'm going to hop into one of the rooms. All right. Nevan, we may have time to hear from only one person, maybe. We have, shall we leave some time for open questions? It's about 10 minutes to go for 7:30 to 7:30.
Team Cytobrush takes 10 seconds. Theirs is super easy, but it's perfect. Maybe you have one too?
What's that?
Call on Team Cytobrush.
Okay.
And maybe grab another team if you have one more. Let me check, make sure they can actually.
If you are sharing something, we can't see Nevan.
I'm not yet, but I will be. But thank you. Let me fix that. It breaks every time I go to a room. I lose my share. There, we're back. All right, Chintan, you want to call them back?
Yes, good idea.
Can we ask a question?
Yes, please.
So this MCM, the most critical element, is it for the chosen strategy or is it from the customer perspective?
This is for the engineering team. So once you've made your strategy, once you start having your initial design, what's the key piece that you put all your design effort into?
Okay, thank you. Yeah.
That's a good question.
As we were thinking, we had 3 strategies we had chosen, and depending on what the most critical element may be different.
Well, that's okay, because if you
No, that's fine. Yeah, I just wanted to know whether like now it's clear. It's for the engineering team because of the limited resources that we have. We want to focus our energies on something. Okay,
yeah,
thanks.
and you know, it's kind of fun if you have 2 strategies or 3 that you like, and then you have to pick. You can also look at the most critical module and say, well, that's going to be $1 million engineering effort to make that most critical module happen. Whereas on the other technology, we have an off the shelf that we can adapt and then make a commercial decision. You may say the first means we need to do a research project, and if we're not Bell Labs, then we don't have the resources. So that's actually very great if you start looking, it's all recursive. If you start looking at that up front, you get a sense of difficulty and cost.
Thanks, Nevan.
Looks like everybody's back. Nevan, you were suggesting we hear from somebody.
I was suggesting,
shall we hear from Cytobrush? And now, is somebody here from Cytobrush?
Do you mean Team Pragmatic?
Yes.
Okay. Okay. So here's what Team Pragmatic. Can you now go through the whole thing? That is, here's my mission statement. Here's how my solution is going to work, right? And this is the most critical module and the risk that I will be mitigating.
Okay. So our mission is to increase the adoption of periodic pap test along with triage to overcome the barriers of privacy and stigma of physical pelvic examination. Okay, that's our mission. Coming to the problems and solutions, as compared to the self-sampling devices available globally, the problems are to reach the transformation zone, which we have looked at to fix by designing and deciding on an appropriate length of the average cervical canal. Second problem is it should not, once inside, it should not move axially. So to give that snug fit, we have ensured that the girth of the device is such that it holds tight once inside, and also the insertion is eased by its varying girth dimensions. Third point is the brush needs to be rotated 10 times. So how would the lady understand whether 10 rotations are over or not? So for that, we have introduced a click feature by which she can easily count the number of rotations. Fourth problem is what if a part of the device is loose and stays back in the canal and doesn't come out. So for that, we have ensured that the entire device is a one single molded piece, so that there are no loose things that can come off. I have not noted down the rest of the things that I have filled. So coming to the last MCM that we had filled, the most critical point for us is after the sample is collected, what if the cytobrush gets dislodged for some reason and stays back in the cervical canal? Of course, that doesn't pose a problem to the lady, but it is a failure from the device performance point of view. So for that, we have ensured that the cytobrush is mounted onto the shaft by a snap-fit technology, which ensures that the brush doesn't get dislodged just by any kind of a shaking or a vibration or something like that. It can come out of the shaft only if it is pulled out. So that is how we have ensured that the MCM is taken care of. Yeah.
Can I comment?
Please.
Yeah. So Sayatani, would you say that is the MCM, or would you say that you shouldn't miss the lesion when you're sampling? Isn't that the most important thing, that you get this lesion? So there's a lesion from where you want to sample cells. You shouldn't miss it, right? It'll give you a false reading.
Yes. So for that, we have ensured that the device length is such that by no chance it can miss the transformation zone.
Yeah.
It is definite to collect cells from the transformation zone.
Yeah, so my point only was that the MCM for you, because your whole thing relies on sampling, right? Is that you don't miss the transformation zone. And what you're saying is that you have taken care of it.
Yes, we have taken care of it.
Yeah. So in the table, the MCM, the risk you have mitigated.
Yes.
That's what I wanted to point out.
Yeah. But I think the important point, I think the snapping of the snapping of a part is kind of it's a failure mode in a way. Whereas here, I think not reaching the transformation zone is just fundamental to the very utility of your devices. Yeah.
Right. That's exactly why I chose that to be an MCM. Because even if it is able to reach the transformation zone and collect the cell, if it gets dislodged and stays there, then there is no point. The whole point is defeated.
Interesting. Good. Yeah. Okay, so we are almost at the end. We have only 2 more minutes to finish. Nevan, you want to put together that discover, design, and demonstrate bit, and see if anybody has any questions? Or
you mean that slide? Bring that back.
Yeah.
Let me give people a reflection. So we want to just give people 2 things to reflect on. So the importance of, as you build your most critical module, what's the fidelity that it needs to have? And the way you decide on the level of fidelity is essentially, it has to capture the fundamentals. Doesn't need to be gorgeous, unless of course it's a product which that's your sales pitch, is we're making it a very pretty looking product, in which case then you focus on the form and let the function sort itself out. But you want to evaluate it in kind of 3 blocks. How do I build this prototype? What testing do I have to conduct internally, so in the lab? And what testing needs to be done externally with the users, with the patients, with our customers, to really make sure that I have met my functional requirements? And that shouldn't be random. You need a test protocol. So as you think about the different tests that need to be done, both bench, both in the market, they need to be guided by a protocol, so you gather the actual data you need. And of course, as you move to making sure it fits those customer needs, you need to look at who is your beachhead market, which will really spill into some of the other lectures you'll hear in this series. And what is the burden of proof to prove to yourself and to prove to that beachhead that you really do have the better mousetrap, the better product? And then finally, do your sensitivity analysis. So how flexible are those parameters, those assumptions that you made? Well, what if your assumption is incorrect? Or what if your technology cannot quite reach the specification that you've given it? Do you have flexibility? And then, of course, think, what might I have overlooked? And this is always a recursive process. Then you can go back, reevaluate your functional requirements, reevaluate your specifications as you go through this process. So we want to emphasize that it's not linear. This process that we showed, you keep going back and revisiting what you do, but as you revisit it, keep good records and document. And that's how we basically take you through from the discovery to developing that product and demonstrating your product to yourself, to your customer, and to your investors. And so with that, we're going to do three things. One, Chintan will deploy one more survey. And we know that this was a rush. This was an experiment to see, could we deliver this content via Zoom and via Google Docs? So we really want your feedback. It just has 2 questions. What worked for you? What could be better? He'll drop that in the chat. We're going to put up our emails. You should feel free to reach out. We do this because we love it. We think it's important. And then also, we'll stay around for people who want to ask questions, want to discuss further.
I think there are 2 links. Mukta has also put up our form, so request both to be filled up, please.
Do you already have a form? We can terminate.
No, that's okay. That's fine. Yours has, I mean, a different set of data points. So request people to. Both are very brief, so I don't think it should be a problem.
Okay.
Yeah. So on a lighter note, can you unshare a little bit? Yeah. Nevan, what if you misread your customer, right? Mm-hmm. Have you seen this? Just a moment.
Oh, this is going to be good.
I think I seem to have. Sorry about that. So
oh my.
What if you misread your customer, right? And your customer just doesn't want to get rid of the rat. That's India for you, right? So I don't know if you are aware, there's a temple in India dedicated to rats. Okay.
Oh. There is a temple in India for everything and everybody.
And we also, it's also something which, yeah, people wouldn't want to sometimes really hurt it. So you were right down the right track. So, I just thought the last note you left was, what if you haven't understood your beachhead customer well, right? So fits in quite well.
This is something that should be a part of these slides.
We need to add this.
So I hope everybody has filled up the form. So please do give your inputs. And those will be compiled and sent to you. Our form comes also separately, Nevan, so you'll get some inputs from there as well. So I think this was very interesting, this sequential method of going after the and also the focus on the MCM, I think is aligns very well with what we have been also talking about. And the fact that in most deep tech technologies, the MCM is the real bottleneck. I mean, the real thing that people need to focus on is actually quite important. And going from you know, the functional requirements to the strategy you choose, and then doing an I mean, how to choose your strategy, and from strategy onwards to specific you know, design parameters and so on. That, I think that was a that is actually a very useful method. So is there a written document somewhere on this which we can put up in the um, in the library that we are collecting? Maybe something which you have written up and available.
There's two things. So let's make sure we put a link to Alex Locum's larger slide deck. It's great. It's wonderfully rich. It looks goofy, but as you dig in, you realize that through all the fun, that's where the learning's happening. And I think we can share these slides to the library, Chintan. Shall we do that?
Yeah, sure.
Okay, great. So those Anmol, let's put up the links up so that we can
yeah. So we tried to, I mean, this is the first time we have kind of used a combination of slides and this kind of Google exercises, because we obviously are teaching in a classroom usually. So it's a very interactive, walking around type of a deal, and very noisy. So hopefully, you know, it wasn't too distracting for everybody to go back and forth between things.
is there a version of this with an example? Has Nevan or Alex Locum written it up in a form of a with an example or illustrative example?
I don't think there's any one size fits all example that goes the whole way through, but that's something we should think about creating.
But as such, in your class, Nevin, every semester there's, or every year there's a whole bunch of examples, but they are all as applied to their own work. Yeah. Right. Yeah.
Yeah. Okay. So I hope everybody has taken the opportunity to fill up the form. Anybody has questions, they can raise it. We here for a few more minutes. Nevan, it's I hope a few more minutes, right?
Whatever.
Yeah. So Anmol, you can keep it open.
Sure.
Premnath, I can ask quick question.
Yeah, please go ahead. Yeah.
Hi, this question for both Nevan and Chintan. See, some of the parameters, you know, when we draw the functional requirements, they could be social, they could be emotional, etc. How do we quantify them and bring it into a structure?
Can you give just a little more of an example we can work off?
Well, let's say, you know, this classic example, iPhone, right? It's not just the functionality, it's also the prestige of having, you know, an iPhone, right? That also sells the product, right?
Ah, interesting. So there is, of course, the technology benchmarks around CPU speed, time to load. So obviously there's definitely literature we could find on between a click and response. How long does it take? And if it's above a certain threshold, then actually users get very frustrated. So those are all technical specs we can find info. So you want to capture like why it's shiny, it's beautiful. What's that worth? It's a great question. That's the first time someone has asked us.
Yeah, this is a great question. Very good and very hard question, actually. So I think, so here are a few thoughts. First of all, this exercise was about more oriented to engineering. But if you, a lot of times people say, oh, this iPhone, look at iPhone, it's so slick and easy to use, a great product, and so on. But they often forget that it is also the best engineered product. So even if it didn't look good, it would have a great performance first. So I think that's the first piece. And I think today's conversation is about that first piece in some. Then there's this question of what are the latent needs that people care about, right, for the product. So this is, what do they dream about? What do they, and that dream is what it speaks to about their image or whatever it is. And that latent need is a piece that today's methodologies wouldn't really let you get to, but there are other methodologies like the empathy maps and so on will let you get to that latent need. And so you will have to combine something like this, which gets you a solid engineering foundation with another anthropological approach, which lets you understand the latent needs in order to arrive at that package called the iPhone. That's how I think about it.
Sure.
Chintan, the best example we ever had, and I think it's fabulous that you use the word latent needs, was Mr. Tata when he gave a lecture to all of our students on why the Nano didn't do well.
Yeah.
So they had done value engineering, which is a double-edged sword, to remove as much cost as humanly possible from the vehicle, got it down to the world's cheapest car, but the engineers, I think, had a field day, but they had completely missed the latent need for the fact that if someone upgrades to a vehicle from a four-wheeler from a two-wheeler, that is an upgrade in their status, both perceived to themselves and perceived to others. And then if they didn't want to buy the car that screamed to the world, all I could afford was the cheapest car. And that was a massive fail. The only way they started recovering from that was by thinking about their branding more carefully and branding it as it's the smart consumer who buys the Nano because they're getting a lot of value for their rupee. The phrase in American English is bang for your buck, and I'm not entirely sure. Chintan, can you fill in the appropriate Indian technical phrase?
That's familiar. That's not
okay.
a problem.
Good.
Yeah.
Thanks.
The bang for your rupee just doesn't sound right to me.
So,
the takeaway point then is engineers, it's very easy for us to be super arrogant and believe the engineering drives the product, but we actually have to make friends with the marketing people and the social scientists because they do have other skills that they will contribute that will basically be as important as good engineering in a product.
Yeah, and by the way, those parameters are becoming increasingly important in many ways. It's not just about prestige, but it's also, for example, environment. A perception issue also. Not everybody looks at a life cycle analysis, but there's a perception issue which can kill a product or make it fly, right?
Yes.
Yeah. So how do you quantify that? That's another challenge. So
I also want to add, Premnath, there is a very important point. But when Nevan referred to this session where Mr. Tata spoke to MIT students, one of the things that he mentioned, which was quite interesting, was that you do reach a point in product design or selection where you almost have to rely on either your own or somebody's intuition that this is what's going to click, type of a thing. That he said, that's the piece that's always very hard to describe.
Yeah, and it's also creating an image around it, right? Like say a Gucci bag, or how do you build that? How do you do that, right? So yeah, very much so. I mean, I can understand where Bala is coming from because there's a lot of these kind of things which have value for people, but how do you build functional requirements and engineering specifications for it? So, yeah.
But what is it that people value? Getting to know that is the first bit, right?
Yeah.
Then you can say that you are trying to maximize whatever it is that people care for.
Yes. Yep.
So, Chintan, this is Ishita here. Coming back to Bala's point, when iPhone was introduced, it was actually engineering wise a very superior product because before that we only had feature phones.
Yeah.
So while it may be sleek and all that, but the you know if we apply today's methodology, it sort of is aligned. It's
Yeah,
only
yeah.
now that there are so many other companies and products and phones that have similar features that are smartphones, and therefore, in fact, the value of iPhone is coming down because there are others who are also there providing similar features, and therefore now it's the next level of next generation of phones that need to be now introduced.
Yeah, no, that's precisely what I was saying. That after all its appeal in terms of the whatever it is that people care for, the image or the perception, etc., etc., what they want to be seen associated with, all of that is, of course, very important. But underneath that is a solidly engineered product. That is what this today's conversation speaks to.
And
So
you
you
can
can't
apply.
really, this is not a substitute. You can't have something really fancy, but it doesn't really work.
Well, the other thing too is even if we think about user experience, I can't quite capture the Gucci aspects in engineering terms, but we could certainly take some of the user experience, which is what makes iPhone the phone of choice for my parents' generation because they can actually use it. And you can say phone must be operable by people over 70. So, or phone people, and then you can do a study to see how long it is that takes people to learn the new features. I have a colleague, he applies the 2-click rule on something consumer facing and non-complicated. No action should require more than 2 clicks, and if it does, he dumps the product in a garbage can because he's too busy. So you can actually create some specifications. All settings should be accessible in under 2 clicks. Any setting the user would need to change.
Yep.
So there's definitely ways to create specifications out of what engineers would say, well, that's just fluffy. Well, not necessarily. We just have to defluff it so that our design teams have something to design against.
Yeah. So Gucci could be about, say, very limited number, selections, uniqueness, whatever, those kind of things. Yeah, and but there's also some amount of eliteness also comes from some special features like Ferraris, versus the story of how Ford was trying to compete with Ferraris, right? And trying to demonstrate a car of that.
Remember how many of some of the old luxury brands, so we think of like Rolls-Royce as the rap star mobile because they spend offensive amounts on their vehicle, but in the old days, vehicles like Rolls-Royce would compete in the Le Mans 24-hour race to prove reliability. So that's what actually drove those brands. And even Gucci, you still, despite paying a huge premium, you believe that you are receiving a product where there will not be a single stitch wrong. So you can Gucci only works if that's true. So you can actually have a Six Sigma quality specification on top of your production.
But they could also be selling you one of a kind. Yeah, that's another thing that they do. They don't have too many of the same type. Right?
Gucci, and again, it's riding on the emotions that one already exhibits in other works of that customer segment exhibit in other works of life. Yeah. But now also we have to remember, all of this conversation reminds me now of Robert Solow, who said that brand is the only concept that economics cannot explain. So, so there is something mysterious beyond all of the rationalization. So,
hey, we have a hand up from Ashish.
Yeah, if I may, I thought I'll just mention one point. Yeah. So once if any company cracks of how to make a good product, I think will they eventually transition into them building a whole aura around it, or the whole concept of how say Apple builds a sort of a story or the prestige concept around it and desirability aspect, because now that they have cracked the whole engineering part of the product. Do actually companies do this transition and get into how should they go about building the whole perception once they have cracked the building part of it? If you have any comments on that.
So companies seem, at least my understanding is that companies today seem very aware of the need to do that. That's for sure. Only